Okay, so this is the proof that is similar to your homework. And as I said in class, some of you laughed. This is kind of a little sleazy proof, but this is the way we show, in general, the typical format we show something is unique. So in this particular problem, I'm showing that the identity element in a group is unique. The game plan typically is to assume there's two different objects, in this case the identities, and then show that they're equal. So assuming that there's two identity elements in G, then my no, which is I have a group, so I have all the conditions of a group, an identity element by definition leaves things unchanged. So A times E is equal to E times A is equal to A, where by times I mean the asterisk. And I also know the same thing is true for E prime because E prime is an identity element as well. Now, I did something in class, and I pointed this out, that I did the George Foreman here. I named this A and I named this A. So I shouldn't name all my variables A, but it's already been written up. So I will abuse myself as I'm going through this proof that I should have called maybe the second element B. So copied and paste my no on this slide. I'm going to start with E prime. Well, E prime is really E prime times E from the starred piece up here, substituting in A equals E prime. So E prime E is equal to E. Okay, so then if I go to the second one here and substitute for A E, I get E prime E is equal to E. And so there, by chaining together all my equalities, I get E prime is equal to E. Since E prime is equal to E, I don't really have two different identities. I have one and the same, and the identity is unique. So for your homework, you're supposed to show that inverses are unique. What you'll do is start out with an element A, assume that it has two inverses, call it B and C, and similar to what I've done here, you're going to show, using the rules of groups, that these two inverses are identical. All right, good luck. Ask questions. Thanks.